Hello, here is a question from the WJEC from 2009. It's a parametric equations question. I'll read you through the main details of it. So we've got a parametric curve. The x value is given by t squared and the y value is given by t cubed. And we've got a point that has parameter little p. It seems a bit strange. I'll get to that in a bit. We've got to show that the equation of the tangent is 3px take away 2y equals p cubed. So we've somehow got to come up with that formula. Just to get this little detail here out the way about the parameter p, this just gives us coordinates of this point p. To get them, we're just plugging little p in here. It might seem a little bit pointless at the moment, but it just means that all the letters will match up eventually. So to get the x value, we just replace the t with a p to get p squared, and the same for the y to get p cubed. So that's our coordinate for p over there, p squared p cubed. Let's talk about the tangent. To get the tangent, I've written the process down here. We're going to need to find dy dx, so we'll differentiate x and y separately with respect to t, and we'll use parametric differentiation. Once we've done that, we'll get our gradient, then we'll use the equation of a straight line to string it all together. So let's do some parametric differentiation. First of all, we know the x value is given by t squared, so dx dt is going to be given by 2t. Similarly, I can differentiate the y, and I can get 3t squared out from that. If I want dy dx, I will divide one by the other there. So I can get dy dx by differentiating, dividing dy dt by dx dt. So I'll have 3t squared divided by 2t, and one set of t's are going to cancel here. And I'm going to get 3t over 2. And because I want the gradient at the point P, again, I'm going to do some seemingly useless substitution. I'm just going to replace the t in this expression with a p. So I have my gradient at a specific point on the curve. All right, from here, I'm setting up the equation of a straight line. I know a coordinate that the tangent passes through. It's the point P, so it's p squared, p cubed. So those are going to give me x and y values. I also know the gradient, which is 3p squared over 2. So if I put that into the equation, I'm going to hopefully be able to get c out. Let's try that. So p cubed here, 3p over 2 here, p squared here. And if I just tidy that up just a little bit, I'm going to get a p cubed over here now. And I can group these terms together. I'll just take it all over to the left side. And 3 over 2, it's 1.5. 1 p cubed take away 1.5 p cubed is going to leave me with minus a half p cubed. That's my constant term. If I plug that back into the equation of a straight line, I'm going to use m is 3p over 2, and I'm going to use c as minus a half p cubed. And you can see some similarities with what I'm supposed to get with what I've got at the moment. What I'm supposed to get doesn't have any fractions, so I'll multiply through by 2 to get the equation 2y equals 3px minus p cubed. And now I do have all the ingredients, just not in the right order. So a little bit of rearranging. I'll actually take the p cubed over to the left hand side 3px take away 2y, and even though I've got the left and right hand sides the other way around, I've got the problem sorted. Alright, here's part B of the same problem. We've got this tangent that we've just found the formula for, and that tangent crosses the curve again down here at the point called Q. We're given a p-value, we're told that p is 2. We're supposed to come up with this equation, q cubed minus 3q squared plus 4 equals 0, and we're supposed to solve it to work out what q is supposed to be. Let's try that. Let's start by writing the tangent equation down once again. 3px minus 2y equals p cubed. Now, we were given a value of p as 2. So I think a good thing to try and do first of all would be to substitute this value in to this equation. Let's do that first. We'll replace the p terms. Let's see what we get. So we're going to get 3 lots of 2x, take away 2y equals 2 cubed, and if I tidy that up a little bit, I'm going to get the formula 6x, take away 2y equals 8. And what I also know, I'm supposed to get some q values out from this. It's a little bit hard to see at the moment, but you might notice that these numbers 6, 2 and 8 are in the same ratio as 1, 3 and 4. So we are along the right lines already. What we're going to do, because we're figuring out a point on the tangent where the curve hits again, we're going to plug in the coordinates of q, which are q squared and q cubed, in for x and y respectively. So let's do that. Respectively, yeah, whatever. 6x is q squared. That's q cubed. Let's divide it through by 2. So we're going to get 3q squared, take away q cubed, equals 4. And if I just rearrange it just a little bit, I'll take everything over to the right hand side. I'm going to get q cubed, take away 3q squared, plus 4 equals 0. Wonderful. Okay, so to get the value of q that I need to solve that equation. How are we going to do that? It's a cubic equation, so I could do some sort of long division. I suppose we could just factorize it on the calculators if we're feeling lazy. I will include all the steps on here. I think that if I plug in 2 in this equation, it should be a factor, because I know that it crosses, the tangent crosses up here when p is 2. So if I just try q is 2, I'm pretty sure that's going to solve. Yeah, that solves. Cool. So one of the factors is q minus 2. And I can do a long division and I can see what else I should get. Let's try it. Q minus 2 and q cubed, take away 3q squared. I need to include the 0q term here just so nothing goes wrong. And I'll go through the long division process. I won't do too much explanation. I think this should be okay here. So I get q squared minus a minus, minus 3 take away minus 2. It's going to take me up to minus 1. And another bit here, so if I multiply that through, I'm going to get minus q squared plus 2q. It's going to give me minus 2q here. So I'm going to get a minus 2 up there. Let's bring that down. And then if I just multiply that just to check that it works, minus 2 times minus 2 is plus 4. Yeah, it does work. Lovely. Great. So what I've just worked out is my cubic equation can be expressed as q minus 2, q squared minus q minus 2. And this quadratic that I've just come up with, I think it can factorize a little bit further. I'm going to get, I think it's going to be minus 1 or maybe plus 1 and minus 2. Yeah, plus 1 minus 2. So this was the value of p. This is the point up here. This must be the value of q.